Hi everyone, welcome to My Maths Academy. In this session, we will continue with the chapter relations and functions from your 12th standard CBSE Mathematics. We will continue from exercise 1.2 in page number 10 of your textbook, problem number 3. So what is given is f is a function from R to R, set of real numbers to set of real number, such that f of x is equal to box x, where this box s is called as greatest integer function, which you would have studied in your 11th standard. What is the meaning of box x? Box x denotes the greatest integer less than or equal to x, which you might have studied in your 11th standard, the different types of functions. One of them that you would have studied was greatest integer function. So what it means is, suppose if I want to find f of 1.3, that will be box 1.3. And what is box of 1.3? Box of 1.3 is the greatest integer less than or equal to 1.3. So which is the greatest integer less than or equal to 1.3? That is 1. Greatest integer less than or equal to 1.3 is 1. Right? That is the greatest integer. You can't find any integer that is greater than 1 but less than or equal to 1.3. We have 0 also, an integer which is less than or equal to 1.3, but 1 is also there, which is the greatest integer. Among all the integers which are less than or equal to 1.3, which is the greatest integer, which is 1. Suppose if you want to find f of 3.7, that is box of 3.7, which is 3. Greatest integer less than or equal to 3.7 is 3. So suppose if you want to find the value of f of 2, f of 2 is box 2 and box 2 is 2, because the greatest integer less than or equal to 2, less than or equal to 2 is 2. Right? So that's how it goes. Now, so now what we have to prove, we have to show that it is neither 1 to 1 nor 1. So what we have to prove? We have to prove that f is not 1 to 1, and we should also prove, that is first one. Second one is, we should prove f is not onto. We have to show that f is not 1 to 1, and we have to show that f is not onto. Now, how do we show that f is not 1 to 1 and f is not onto? Right? So for that, so to show that it is not 1 to 1, the proof is, or solution, whatever. Now, so if we can show that two elements in this R, if they go to the same element in the codomain R, then it becomes not 1 to 1. See, if you try to understand the function, how it looks like is, this is R to R. You have all, suppose if I have 1, 2, 1.5, 2.7, 3.8, minus 1, minus 2.9, all that. So here you have 1, 2, 3, 4, 5, minus 1, 1.1, minus 3.9, minus 2.8, 0.6, and all that. So minus 3, minus 9, all the real numbers. Right? Suppose what is box of 1? F of 1 will be mapped to f of 1. 1 will go to 1 because box 1 is 1. Similarly, f of 2 is box 2, that will also go to 2. 1.5 will go to 1 because box of 1.5 is, suppose if we take 1.3, doesn't matter. 1.3 is 1. So similarly, 2.7 will go to 2. 3.8 will go to 3. Minus 1 will go to minus 1. Minus 2.9 will go to minus 3. Because box of minus 2.9 is what? Don't think that is, so box of minus 2.9 means, if you want to find f of minus 2.9, that is equal to box 2.9 is minus 3. That is the greatest integer less than or equal to 2.9. We can't say minus 2 here. We can't say minus 2 because minus 2 is not less than or equal to minus 2.9. Minus 2 is greater than minus 2.9. So the greatest integer that is less than or equal to this value, you have to write an integer, and that integer should be less than or equal to this, and that should be the greatest integer less than or equal to minus 2.9, which is minus 3. So minus 2.9 will go to minus 3. So that's how this function is. Now if you look at the function, obviously if you see, right, this 2 and 2.7, they go to same 2. Even if I have 1 and 1.3, even if I take 1.7, 1.7 will also go to 1. 1.3 also will go to 1. 1.7 also will go to 1. So clearly it is not 1 to 1. Right? So we'll take two numbers. So we'll say f of we'll take this 1.3 is box of 1.3, which is 1, and f of 1.7 is box of 1.7, which is also 1, which means two different elements, both are real numbers. Two different elements have the same image. When two different elements have the same image, then it is not 1 to 1. So therefore, we'll say therefore f is not 1 to 1, because two numbers have the same image, 1.3 and 1.7, 1.3, 1.7, both go to 1. Even 1 also goes to 1. Right? Next one is to prove that is not 1 to. Now clearly if you see all these numbers, they are going to only integer values. We will not go no number will go to 1.1 or 0.6. No number here will be mapped to this, because all these will go only to integer, because the output of this function, the result of this function, this box x will be always an integer. So only the integers will be image of some element here. So if you take any non-integer value, suppose if I take minus 3.9, this does not have any x here, such that f of x is minus 3.9. You will never find any x here such that f of x will give you minus 3.9. So it is not onto. You can take 1.1 also, or 0.6. Any number which is not an integer will not have any x here such that f of x is this. Right? So to prove that it is not onto, we can just show one element which is not an image of any of the element here. If you can find one element which is not an image of any element here, which means no element is mapped to that element, 0.6, then it is not onto. So we'll say we can take 0.6 or 0.2, anything. We can take 1.1. So we'll say 0.6 belongs to R, and this R is codomain. This R, not this R. This R, codomain. But that does not exist any x belonging to this R. This R is domain R. See, both these sets are different, then we not say domain and codomain, because when we write R, we know that which set we represent if these two are different. When these two are same, then it's better to say from which R we are taking, whether from codomain or from domain. So we always, to prove or disprove it is onto, we'll take an element from the codomain, and we say that we are not able to find, does not exist any x in R such that my f of x will give me 0.6. My f of x will never become 0.6, such that f of x is equal to 0.6. Therefore, f is not onto. F is not an onto function. Clear? So all of you can take the notes. I'll go to the next problem. Next problem is problem fourth question in your exercise. So what is given? F is a function from R to R, and f of x is defined as mod x, which is your modulus function. Fine. F is a modulus function. F is positive, 0, or okay, right? F is a mod function. Now we should show that f is not 1 to 1, not onto. Same way we have to show this. Now let's try to understand this function, mod function. Right? We also have a definition of mod. The definition of mod is also defined as the f of x is mod x, means we can also define f of x in this way, which is the definition of mod x is set of all is x when x is greater or equal to 0, it is minus x when x is less than 0. Both are one and the same. Mod x means the definition of mod x is f of x equal to x when x is greater or equal to 0. It becomes minus x when x is less than 0. So both mean the same. Right? So now let's try to understand how this function is. Right? So you have set of real numbers and set of real numbers. If it's put 0. So we have 0, 1, minus 1, 1.1, 2.1, minus 2.9, 3, and then minus 2.1, etc. Here you have 0, 1, minus 1, 1.1, 2.1, 3.1, minus 2.1, minus 9, 3, 8, or and all the real numbers. It goes on. It has all the real numbers. Now 0 goes to where f of x is mod x. F of 0 is mod 0 is 0. 1 goes to 1. F of 1 is modulus of 1. Modulus of 1 is 1. Absolute value. Minus 1 is will also go to 1. Because mod of f of x, f of minus 1 will be mod of minus 1. That is 1. Modulus of minus 1 is 1. Right? So 1 also goes to 1, minus 1 also goes to 1. So clearly this shows that it is many to 1, which means it is not 1 to 1. So similarly 1.1 will go to 1.1, to minus 2.1 will go to 2.1. And 2.1 also will go to, right? Then 2.9 will go to 2.9 plus 2.9. So 3 will go to 3. Minus 3 also will go to 3. You have minus 3 also here. So this is how the function is. Now clearly it shows that the function is not 1 to 1. So we will have to take one example and say that two elements in the domain have the same image. So which means we will say f of 1 is modulus of 1, which is 1. F of minus 1 is modulus of minus 1, which is also 1. We can use either this function or this function. If you want to find the value of f of minus 1 using this function, now f of minus 1, right? F of minus 1 is x is negative. When x is negative, you have to use this function. So your f of x will become minus x. So your f of minus 1 will become minus of minus 1, which is 1. F of minus 1 is minus of, if you use this function. If you either you can use this or this, because both are the equal function. Both are one and the same. Mod x can be rewritten like this. A definition of mod x is this. So whenever your x is negative, here x is minus 1. So I should not use this function, I should use this function because x is negative. So it is f of x is minus x, which is minus of minus 1, which is plus 1. So f of minus 1 is 1. So f of 1 is also 1, f of minus 1 is also 1. So therefore, f is not 1 to 1. Because both two elements, 1 and minus 1, they go to the same element. Then it is not 1 to 1, it is many to 1. Many are going to 1. So it's not 1 to 1. Similarly, we have to prove that it is not onto. So obviously, if you see the function, right? You see that your modulus function will be always will give you non-negative value, which means either it will give you 0 or positive value. This can never become negative. Your f of x is mod x. This will never become negative. So all these numbers, if you see, they go to the positive value only. Minus 2.9 will go to plus 2.9. Right? So minus 2.1 will go to plus 2.1. So the negative numbers, they don't have any, negative numbers cannot be imaged, which means if I take minus 1 does not have any number here such that f of x is minus 1. So minus 1 cannot be image of any element here, or no element will be mapped to minus 1. Therefore it is not onto. So how do we prove? We'll say minus 1. We'll say minus 1 belongs to R. We have minus 1 belongs to R, which is codomain, but there does not exist any x in R domain such that f of x is equal to minus 1. Therefore, f is not onto. So this is how we prove that f is not an onto function. So if is not 1 to 1, f is not onto. So all of you can take the notes. I will go to the next problem, which is problem number 5. So given as f is a function from R to R and f of x is defined as f of x is defined as 1 if x is greater than 0, 0 when x equal to 0, minus 1 when x is less than 0. So this is called as what function? Signum function. Again, you would have studied this in your 11th standard. This is called as signum function. This is called as a signum function. Right? So here is these. Now we should show that it is again neither 1 to 1 nor onto. You have to show that it is not 1 to 1, it is not onto. Now how does this function look like? This signum function, if you try to draw this, suppose again it's R to R. So we have all these numbers. We have minus 1, 0, 1, 2, minus 2.1, minus 3, 3.5, minus 4.5, root 2 and all that. So here you have minus 1, 0, 1, 2, 3, minus 5, minus 3.5, minus 3, minus 2.1, all this, dot, 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 dot. Now where will it go? Now let's take, what is f of minus 1? Minus 1, f of, what is f of minus 1? Minus 1 means x is negative. X is negative means f of minus 1 will go to minus 1. Negative number will go to. Now 0, when x is 0, f of x is 0. So x0 will go to 0. 1, x is greater than 0, 1 will go to 1. Sorry. 1 will go to 1. 2 is what? 2 is greater than 0. This 2. 2 is greater than 0. So 2 will go to 1. So f of 2 means, f of 2 is what? So x is 2. F of 2 means x is 2. 2 is greater than 0. Therefore, your f of x will be 1. F of 2 also will go to 1. F of minus 2.1. Minus 2.1 is negative. So x is negative means f of x is minus 1. So minus 2.1 will go to minus 1. Minus 3 also will go to minus 1. All negative numbers will go to minus 1. All positive numbers will go to 1 and 0 will go to 0. These are the definitions of the functions. Now obviously, if you see, right, it's definitely not 1 to 1 because even 1 goes to 1, 2 also goes to 1. Right? 1 goes to 1, 2 also goes to 1. So two different elements go to the same number, therefore it is not 1 to 1. So we'll say f of 1 is 1 as per the definition of this function. And f of 2 is also 1 because all the positive values. F of 1 means x is 1, which means x is greater than 0 means f of x is 1. 2 means again x is greater than 0, so f of x will be 1. So therefore f is not 1. So 1 also goes to 1, 2 also goes to 1. So two different elements have same image, therefore it is not 1 to 1. So similarly, if you see here, all the elements here, they get mapped to only these three elements, minus 1, 0 or 1. The range is only three elements. The range of this set is what? Set of all mapped elements. The range is what? Range is minus 1, 0 and 1. All the elements in 3.5 will go to 1 because positive. 3.5 will go to 1. Minus 4.5 will go to minus 1. So all the negative numbers go to minus 1, all the positive numbers go to 1. So which means there are other numbers like 2, 3, they don't have any x here, so that f of x is this. The other elements cannot be image of any element here. Therefore it is not on 2. So we'll take one element. Suppose if I take 2, then I cannot find any x here such that f of x is 2. No element here will be mapped to 2, or no element here will be mapped to 3, or no element here will be mapped to minus 5. There are many elements like that which are not image of any element from the domain set this. So we can take one element, we'll say minus, we cannot say minus 2. 2 belongs to our codomain, but there is not any x in R such that f of x is 2. Therefore, f is not on 2. F is not onto function. Fine. So all of you can take the notes. I'll go to the next problem. Sixth one is, given f is a function from set A to set B, f is a function from A to B. F is a function from set A to set B, and A set is given as 1, 2, 3. A is 1, 2, 3. A is 1, 2, 3, and our set B is 4, 5, 6 and 7. And let f equal to, so they have given f also. How is f? F is given as 1, 4, 2, 5, 3, 6. Now what we have to show? We have to show that f is 1 to 1. We will show that f is a 1 to 1 function. The definition of the function is given like this. To prove f is 1 to 1. We have to prove that f is a 1 to 1 function. Now how does this look like? Let's try to draw the arrow diagram for this. So your A set is here, which is 1, 2 and 3. Your B set is 4, 5, 6 and 7. This is your B. And how this f is mapping is 1 is mapped to 4. That is the meaning of this. 1, 4 means 1 is mapped to 4. So 1 goes to 4, and 2 goes to 5, and 3 goes to 6. Now clearly what? It is a 1 to 1 function because no two distinct elements have the same image. No two or no distinct element, no two distinct elements have same image, right? Or the distinct elements in A have distinct images, right? So we'll say uh, the so from the definition of F, it is clear that because it is a very small, it's a very small set, and you can clearly see from the arrow diagram that it is 1 to 1. So from the definition of F, it is clear that the image of distinct elements of A under the function F are distinct. The images of distinct elements of A under F are distinct. Which means different elements have different images. If different elements have same image, then it is many to one. If different elements, these two are different elements, they have different image. Image of 1 is 4, image of 2 is 5. An image of 3 is 6. So therefore F is 1 to 1. Therefore F is 1 to 1. So that is a proof for sixth problem. That is a proof for the sixth problem. Now we will move to the seventh problem. All of you can take the notes. Now seventh has two sub problems. So I will do the seventh first part. First, so what is given? F is a function from R to R. F is a function from R to R, and f of x is defined as 3 minus 4x. 3 minus 4x. Now what we have to prove? We have to show that, state whether f is 1 to 1, on 2 or bijective. We have to check whether 1 to 1, on 2 or bijective. Justify your answer. You have to check this, not proving, check. To check f 1 to 1, f on 2. Question mark. We have to check. Check is f 1 to 1. Let's say is f 1 to 1, is f on 2. We have to check these two. They are not saying prove it. We don't know whether it is 1 to 1 or on 2. We have to check, and accordingly we have to say. If it is 1 to 1, we have to prove 1 to 1. If it is not 1 to 1, then we have to find two elements. Two different elements should have same image. Then we can say it is not 1 to 1. Same with the case of 1 to 2. So now, how do we show this now? Proof. Right? So the definition is more. I mean, if you try to do the arrow diagram and start putting the elements, then you know where they get mapped to. If I put 1, f of 1 will go to 3 minus 4 into 1, which is minus 1. 1 will go to minus 1. Then different values of x, you will give different values for f of x. Now, to check whether this, suppose if we don't know it is very 1 to 1 or on 2, we will try to see whether we can prove that it is 1 to 1. If you don't know whether it is 1 to 1 or not, we will try to put different elements and see whether you are getting different elements, different images. If I put f of x as 1, I get, if I put x as 1, I get f of x as minus 1. If I put x as minus 1, my f of minus 1 will be 3 minus 4 into minus 1, which will give me 7. Right? So if I try to find what is f of 1, my f of 1 will be 3 minus 4 into 1, which is minus 1. If I try to find f of minus 1, that will be 3 minus 4 into minus 1, which is 7. So similarly, if I try to find out f of 0, that is 3 minus 4 times 0, which is 3. Now f of 2 is 3 minus 4 times 2, which is minus 5. If I find f of minus 2, that is 3 times minus 4 into minus 2, which is 11. Right? So clearly this looks like it is going to different elements. Right? Looks like it is going to different elements. 1 goes to minus 1, minus 1 goes to 7, 0 goes to 3, 2 goes to minus 5. So looks like it is 1 to 1. So we'll try to prove that it is 1 to 1. We'll see if we are able to prove that it is 1 to 1. So for that, what do? We need to take two elements from this set domain. So let x1 comma x2 belongs to R, which is clearly domain, such that f of x1 equal to f of x2. So we have taken two elements, we have taken two elements x1 and x2, such that f of x1 equal to f of x2. You have to prove now x1 equal to x2. If you prove x1 equal to x2, it is 1 to 1. If you prove x1 is not equal to x2, then it is not 1 to 1. Now we have this f of x1 equal to f of x. What is f of x1? F of x is 3 minus 4x. F of x1 will be 3 minus 4x1 equal to f of x2 will be 3 minus 4x2. Right? Then 3 will get cancelled. You get minus 4x1 equal to minus 4x2. Again minus 4 can be cancelled. You get x1 equal to x2. x1 equal to x2. So we started with the images are same, then the elements are also same. Therefore it is 1 to 1. Whenever you have to prove 1 to 1, this is what you will follow. You will take two elements from the domain and such that their images are same, and you have to show that the elements itself is same. The two elements that we took, they are not different elements, they are one and the same. Suppose the elements are different. If x1 you get x1 is not equal to x2 or some value x1 equal to 2x2 or something, then x1 is not equal to x2, then you will get it is not 1 to 1. So here it is 1 to 1. Therefore f is 1 to 1 function. F is 1 to 1. Now to prove onto. To prove onto, second part, we have to prove whether we have checked whether it is onto. We are not going to prove that it's onto. We are going to check it is onto. But clearly, whenever you have the definition of the function, right? And to check for onto, we'll try to first write f of x, y equal to f of x. We'll always put y is equal to f of x. Right? And y is equal to, what is f of x? 3 minus 4x. Now we'll try to write x in terms of y, which means bring all the x to the left side. So 4x and throw the y to the other side, 3 minus y. And your x will become 3 minus y by 4. So we have written x in terms of y, x equal to something. Now let's check whether this x, whatever we got, x is equal to 3 minus y by 4, is it a real number? We have to check whether it will be a real number, because if y is a real number, 3 minus y is also a real number, and that by 4 is also a real number. So this will belong to R. So which means for every y, if I take my x as this, then it becomes onto. Which means for every y I take from this set, I am able to find an x here, which is in this form. The moment it is in this form, we have to check whether this belongs to this set domain. Yes, 3 minus y by 4 is a real number. So for every y, we are able to find an x such that f of x, we have to show it is y. Then it becomes onto. Right? So we'll say for every y belonging to R. Here this R is this R, which is codomain. There exists x equal to 3 minus y by 4. If I take my x in this form, so this x comes by putting the f of x as y and then getting x in terms of y. Right? For every y belonging to R, there exists an x belonging to R, and this R is domain, such that now we have to find what is f of x. F of x is equal to f of, don't say f of x equal to y, f of x equal to f of x is what? 3 minus y by 4. And that is equal to, what is f of 3 minus y by 4? Use the function definition. F of x is 3 minus 4x. So which means f of this will be 3 minus 4 into whatever is, this is your x, which is 3 minus y by 4. Now 4 will get cancelled. You will get 3 minus 3 plus y. That will become y. So you got your f of x is equal to y. We start with f of x is equal to y. Therefore, f is onto. Because we have proved that for every y in this domain, we are able to find an x here so that f of x is y. F of x is y. So whenever you are not sure whether it is onto or not, suppose you are not sure whether it is onto or not, try to put the arrow diagram. Sometimes it may not be possible to put the arrow diagram for all the functions. Here also you can start putting arrow diagram. This is what, like 1 goes to -1 and all that, right? So you can put the arrow diagram. From the arrow diagram, or when you write the definition, you will feel that sometimes you may get an idea that yeah, it is 1-to-1 or it is onto. Even if you are not sure after writing these or after putting the arrow diagram, then try to write x in terms of y and then check whether it is a real number, whether this belongs to this set. So when I take a y from this set, I am able to find an x from this set, such that if you take f of x for this, you will get y, because the x was arrived using y only. So this is a standard steps or the process that you will follow to prove that f is 1-to-1 or f is onto. Right. Now let's go to the second part of the seventh problem. So second part of the seventh problem is f is a function from R to R and f of x is defined as 1 plus x square. 1 plus x square. Now we have to check if f is 1-to-1 and onto. Now again we will try to write the definite function. So let's try to find what is f of 1 and try to always find for 1, -1 some positive numbers and some negative numbers and 0 and see what it is. Now what is f of 1 as per this definition? F of 1 is 1. Sorry, f of 1 is, as per the definition, f of 1 is 1 plus 1 square, which is 2. F of -1 is 1 plus -1 the whole square, that is also 2. F of 0 is 1 plus 0 square, which is 1. F of 2 is 1 plus 2 square, which is 5. F of -2 is 1 plus -2 the whole square, which is also 5. Now clearly if you see 1 also gives you 2, -1 also goes to 2. So it is many to 1. It is many to 1. And also all the positive numbers are going to positive, negative numbers also getting mapped to positive. Right? Negative numbers are also getting mapped to positive. Right? So if I try to write this, suppose if I put these sets, we have 1, -1, 0, 2, -2. Then we have 1, 2, 3, 4, -1, -5, -6, all that, -7, dot, 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 all 1.1, or even the points are there. 1 goes to 1, sorry, 1 goes to 2. 1 is mapped to 2, -1 is also mapped to 2. So 0 goes to 0, 0 goes to 1, 0 goes to 1, 2 goes to 5, -2 also goes to 5. So therefore clearly it is many to 1. Clearly it is many to 1, so which means f is not 1-to-1. So for that we will take two elements. We can take 2 and -2 or 1 and -1, doesn't matter. So we will take f of 1. What is f of 1? Is 1 plus 1 square. This is a rough work that you will do just to understand how the function is. You need not write this or this in your exam, but if you are confused, you can always draw this and then write this and do the mapping, so that you will get some idea whether it is 1-to-1 or onto. Because here we don't know whether it is 1-to-1 or onto. We are checking. If they say show that it is 1-to-1, then it means it is 1-to-1. We can try to write the proof accordingly. Or if they show that it is not 1-to-1, then we can try to disprove. But whether we don't know whether we have to prove it as 1-to-1 or we should show it as not 1-to-1 means, then we don't know accordingly whether we have to write the proof for 1-to-1 or write the proof for not 1-to-1. We don't know that. Right? So that time you can put some arrow diagram and write like this and try to observe how it is, how it looks like. Whether it is some element, looking at the arrow diagram, you suppose if you see two elements going to one element, then clearly it is not 1-to-1. You can use those two elements and prove that it is not 1-to-1. Right? So f of -1 will give me 1 plus -1 the whole square, because f of x is 1 plus x square. That is also true. Therefore 1 goes to 2, -1 also goes to 2. Therefore f is not 1-to-1. F is not 1-to-1. Again for onto, if you observe again all these elements, this 1 plus x square will never become negative. 1 plus x square can never become negative, or worst case it may become negative. It will never become negative. You cannot get minus value for the entire thing. Whatever value you put for x, 1 plus x square will be only positive. Which means if I take any negative number, minus 1, you cannot find any element here such that f of x is minus 1. If you take any element here, x, such that f of x is minus 1. So any negative number that you take that will not have any number x such that f of x should get mapped to minus 1. So therefore, f is not onto, because there are there are many numbers like that which are not image of any number here. Even if you find one number, it is enough to show that it is not onto. So we'll say, or we can say minus 1 belongs to R, which is codomain, but there does not exist any x belonging to R, which is domain, such that f of x equal to minus 1. So you cannot find minus 1 in 1 plus x square cannot become minus 1. If it becomes minus 1, then your x square will become minus 2. How can a square of a number be negative? Square of a real number be negative. X square equal to minus 2 means there is no x which can give you minus 2, right? So therefore your 1 plus x square cannot be minus 1. It cannot be minus 2 also, minus 3 also. You can even say minus 2 belongs to R, but there does not exist any x belonging to R, which is domain, such that f of x is minus 2. We can write the proof like that also. Therefore, f is not onto. So therefore, f is not onto, which means f is not an onto function. So this is how we prove this. Fine. So all of you can take the notes. I will stop the session here. You can watch my next video for the continuation of this. Thank you for watching. See you in the next video.